Hello, am I audible?
Yes, ma'am.
Okay. So we will start with the lecture. Good morning to all. So your ECAD lecture will be at 10:30 and AC lecture it is at 9:30. As per timetable, ECAD lecture was there, no, at 9:30.
Okay. Yes, ma'am.
Okay. So it will be at 10:30. So what point we have covered yesterday? What points we have covered yesterday? AM receiver we are considering. And in AM receiver, what are the points that we have seen yesterday? Please give the answers. कुठले पॉइंट बघितलेत आपण काल?
Types of AM detector.
Types of AM detector. That point we have started. And before types of the AM detector, we have seen these 2 points, mixer and tracking. हे 2 point आपण बघितलेले. And after that, we have started with the types of the AM detector. Okay, so which type of mixer we have studied? कुठले type आहेत 2 mixerचे? Can you tell? What are the types of mixer?
Frequency mixer and separately excited mixer.
Frequency mixer and separately excited mixer. So out of that we have seen the frequency mixer. Okay, and then that tracking point we have considered. So tracking, it is nothing but it is set of capacitors used to tune the receiver with the transmitter. Okay, that is the tracking process. Then next we have to study AM detector types. So there are 2 types in the AM detector. What are the 2 types in the AM detector?
Envelope detector and rectifier detector.
Envelope detector and rectifier detector. So out of that we have completed yesterday the envelope detector. So what is the working principle of envelope detector? Once again I will quickly revise. So the basic input signal to that detector, it is AM signal. It is quite obvious. Basic input signal कुठला असणार आहे? AM signal असणार आहे. That AM signal is given to the diode. Diode, what is the function of diode? It passes the signal only in the one direction. That's why whenever this AM it is having the positive half cycle, diode will become forward bias and it will come as it is at the output. And when the AM it is having negative half cycle, this diode it is reverse bias. That's why it will act as a open circuit and we will get 0 at the output. That is the working of first part, diode. हा जो युनिडायरेक्शनल मिळालेला आहे AM सिग्नल, याच्यामध्ये 2 कंपोनंट्स आहेत. वन इट इज मॉड्युलेटिंग सिग्नल. हा जो दिसतोय सिग्नल तुम्हाला, स्क्रीन इज विजिबल टू ऑल?
Yes, ma'am.
So whatever is this part, this is modulating signal, and whatever inside the modulating signal, the frequency is there, that is the carrier frequency. So this part we are getting at the output of diode. Diode काय करतो, फक्त negative part flip करून टाकतो and it remains only the positive half cycle at the upper side. Then this output is given to this low pass filter, that is RC filter. So that output is given to this RC combination filter. It is formed with the help of this R and C. And then which type of filter it is used here? Low pass filter or high pass filter? आता modulating signal
Low pass filter.
Yes. Always you remember, whenever there is demodulator side, at that time we are using the low pass filter. नेहमी लक्षात ठेवा, demodulator मध्ये low pass filter आपण use करतो. Okay. So this is the low pass filter. It is used at the receiver side and then we get the output in the form of modulating signal. This is the working principle of the envelope detector. Now the next type of, so here the drawbacks we have seen: sensitivity it is less, no amplification occurs in the diode detector, and advantages are ability to handle a relatively high power signal at input and efficiency it is 90%. हा झाला ह्याचा first type detector चा. Now the second type of detector we are going to see, that is rectifier detector. Okay. So if this is the diagram, you first see the diagram so that you will understand what is the function of rectifier detector. This is rectifier detector. So here additionally one low pass filter it is added. इथं काय केलं होतं आपण, फक्त हा जो डायोड आहे सगळं बेसिक वर्किंग प्रिन्सिपल सेम आहे as that of envelope detector. फक्त rectifier detector मध्ये काय डिफरन्स आहे बेसिक, की हे जे सर्किट आहे ह्याच्यामध्ये one more low pass filter is added so that we get the modulating signal in exact low frequency form. अजून एक low pass filter ऍड केल्यामुळे काय होतं, ऑब्विसली स्टील एनी ह्या मॉड्युलेटिंग सिग्नल मध्ये जर कुठले हाय फ्रिक्वेन्सी कंपोनेंट स्टील प्रेझेंट असतील तर that components are removed and we are able to get the more low frequency or more accurate modulating signal. That is the only difference between the rectifier detector and envelope detector. Okay, so same diagram it is there, you can see. बघा तर पहिलं बेसिक इनपुट काय असणार आहे, ह्याला सुद्धा AM सिग्नल. AM सिग्नलचा आउटपुट कुठं दिला आपण, डायोडला. Output of AM signal is given to diode. Then output of diode it is passed through this resistor, and here one more low pass filter is used. आणि इथं जो हा RC वापरलेला आहे, it is also by default it is forming the low pass filter. So here the additionally one more low pass filter is added. आधीच्या याच्यामध्ये कसं होतं, फक्त आपण इथे कॉम्बिनेशन R आणि C चं वापरलं होतं. इथं काय केलेलं आहे, one more low pass filter is used in combination with this RC filter, and that's why whatever output we are getting here, M of T दिलेले output, M of T represents the modulating signal. Whatever is this output, it is in the exact pure modulating signal form as compared with the previous output, whatever we were getting at the envelope detector. Okay, so this is the difference. So are you getting this? We will see the functions one by one. Overall function फक्त लक्षात घ्या. हा AM सिग्नल, याच्यामध्ये मी तुम्हाला बऱ्याचदा सांगितलं की एनालॉग कम्युनिकेशन मध्ये किंवा कुठल्याही कम्युनिकेशन रिलेटेड सब्जेक्ट मध्ये फर्स्ट यू हॅव टू अंडरस्टँड द डायग्राम. इफ यू आर एबल टू अंडरस्टँड द डायग्राम प्रॉपरली, you can write the description. So whenever you are studying from exam point of view, or some point if you are preparing at 11th hour, first you prepare the block diagram, so that from that block diagram at least some explanation you are able to write. So here AM signal is given as input to the diode. So what this diode will do, waveforms पण सेम असणार आहेत बघा ह्याच्यासारखेच, पहिले जे आपण बघितले सेम ह्याच वेवफॉर्म असणार आहे. त्याला AM इनपुट दिला आपण डायोडला, डायोडचं आउटपुट काय होईल, निगेटिव्ह पार्ट क्लिप होईल, यातून फक्त आपल्याला इथं पॉझिटिव्ह सिग्नल मिळेल. दॅट इज आउटपुट ऑफ द डायोड. अँड देन अगेन at the output of diode here, just this resistor it is again filtering the signal, and in front of the resistor low pass filter is used. In front of the resistor low pass filter is used, which will filter the means it will remove the high frequency components, and just low frequency components will be present at the output of this low pass filter. And in front of low pass filter this RC filter it is used, which will give the exact modulating signal. So which one is having more selectivity if you compare rectifier detector and envelope detector? कशाची selectivity जास्त असणार आहे दोन्ही मध्ये? Selectivity means what? select the signal of the required frequency. Required frequency म्हणजे आपली modulating signal ची frequency आहे. मग जास्त एक्झॅक्ट प्युअर मॉड्युलेटिंग सिग्नल आपल्याला कुठल्या टाइप मध्ये मिळतोय दोन्हीपैकी?
Rectifier.
Rectifier. That's why advantage of rectifier it is due to addition of low pass filter, selectivity of the receiver it is increased. लक्षात येतं का दोन्ही मधला डिफरन्स? फंक्शन बेसिक सेम आहे. आता इथं मी वेवफॉर्म दिलेलं नाही सेपरेटली, कारण वेवफॉर्म इट इज सेम. जर तुम्हाला रेक्टिफायर डिटेक्टर विचारला तर ही ब्लॉक डायग्राम काढायची. एक्सप्लेनेशन आय विल रीड दिस पॉइंट्स वन्स अगेन. Explanation you have to write and the same waveforms you have to draw. AM input, output of diode and VO that is final output. किंवा इथे जर आपण M of T notation वापरलं असेल तर same notation you have to use for the output waveform. Okay? Understood the function of rectifier detector?
Yes, ma'am.
So same it is given here. In this detector type, diode is acting as a rectifier. In front of diode, resistor is connected in series and the output is given to the low pass filter. Then this diode converts AM signal into unidirectional AM. This unidirectional AM signal is passed through low pass filter, which is additional block in the rectifier detector. And low pass filter removes the carrier component and only modulating signal will be present at the output. So this is the working principle of this rectifier detector. Okay, so advantages are due to addition of low pass filter, selectivity of the receiver is increased. That is the first advantage. Okay, and another advantage you can say here that whatever modulating signal we are getting at the receiver, it is in pure form as compared with the modulating signal whatever we are getting in the envelope detector. Okay, so these are the two types of AM detectors. Okay, मग जर तुम्हाला AM detector वरती क्वेश्चन विचारला तर दोन्ही टाइप लिहायचे. You explain any one type, or if any specifically particular detector is asked, that detector you have to write. Okay, so this is about the AM detector. So I hope you are clear with the point. AM detector. आता आपण ट्रान्समीटर मध्ये काय काय बघितलं होतं बघा. बेसिक AM सिग्नल ट्रान्समीटर, then generation of DSB-SC signal and generation of SSB-SC signal. Similarly, here also in the demodulator we have to see, आता जे आपण डिटेक्टर बघितले ते प्युअर AM चे डिटेक्टर होते. सिक्वेन्स लक्षात घ्या. ट्रान्समीटर मध्ये सुद्धा आपण कसं बघितलेलं आहे, जनरेशन ऑफ प्युअर AM सिग्नल, then generation of DSB-SC signal and then generation of SSB-SC signal. Similarly, for detector also we will see AM detector, then DSB-SC detector and then SSB-SC detector. Okay, then AM detector now we have considered. Now what is the next point? What are another two forms of AM signal?
DSB-SC and SSB-SC.
DSB-SC and SSB-SC. So after AM detector, now we have to see the demodulation of DSB-SC signal. And after this, we have to see demodulation of SSB-SC signal. Okay. So can you tell what are the circuits used for DSB-SC signal generation? किंवा AM पासून बघू आपण. Let me check how much you remember. AM जनरेशन साठी कुठले दोन सर्किट आहेत? AM जनरेशन. What are the two circuits for AM generation?
Multiplier modulator and switching modulator.
Multiplier modulator and switching modulator, correct. Then for DSB-SC generation, what are the two circuits?
Balanced modulator and ring modulator.
Balanced modulator and ring modulator. Okay, and for SSB-SC generation?
filter method,
filter method, phase shift
Filter
method,
phase shift method, and
Weaver's method.
रिव्हर्स मेथड. त्यातली आपण कुठली बघितली सिलेबस मध्ये?
Filter method.
Filter method. Okay, so I hope you are clear with that. So now we are going to see the demodulation for DSB-SC. And detector मध्ये दोन टाइप आहेत, envelope detector आणि rectifier detector. After that we have to see the process for demodulation of DSB-SC signal. So I hope you are understanding the flow. Now we have to see demodulation of DSB-SC signal. Now whatever method is used for demodulation of DSB-SC signal, that is called as the synchronization method. किंवा ह्या मेथडला जनरली काय म्हणतात? Synchronous method, which is used for this demodulation of DSB-SC signal. आधी पहिल्यांदा आपण ह्याला synchronization method किंवा synchronous method का म्हणतात? That we will see first. Now in the generation of DSB-SC signal, तुम्ही जर आता कन्सिडर करा, तीन फॉर्म आहेत. AM फॉर्म, AM नंतर कुठला आहे? DSB-SC. And after DSB-SC, which form is there?
SSB-SC.
SSB-SC. Okay, so I will just write here so that you will understand. Give me 1 minute. Okay, so I will just write here in the word file. AM minus carrier, that is giving you DSB-SC. DSB-SC minus one sideband, that is giving you SSB-SC. That is at the modulator side. Okay, so I will write here AM minus carrier, that is giving you the DSB-SC signal. हा झाला पहिला फॉर्म. आणि DSB-SC, this is first form. Then DSB-SC minus one sideband, any sideband. It can, so I will write here minus so that you will understand. कारण इथं दोन्हीकडे dash dash होत आहे. AM minus carrier, that is giving you DSB-SC signal. Then DSB-SC signal minus sideband,
SSB-SC signal.
DSB-SC signal minus sideband म्हणजे काय म्हणतात आपल्याला? SSB-SC signal. These points are there at the which side? Transmitter side.
Yes.
These points are there at the transmitter side. Now, if you have to recover the DSB-SC signal, directly you cannot recover DSB-SC signal. आता रिसिव्हरचं मी याच्या पुढे किंवा खाली लिहिते so that you will understand. रिसिव्हर मध्ये बघा, जेव्हा आपल्याला DSB-SC रिकव्हर करायचं असतो तेव्हा डायरेक्टली आपण DSB-SC रिकव्हर करू शकत नाही. आपण AM मधनं कॅरियर मायनस करून DSB-SC घेतलेला आहे, जनरेट केलं आहे, बरोबर आहे. मग रिसिव्हर मध्ये किंवा डिटेक्शन मध्ये काय करावं लागतं? DSB-SCच्या इन द DSB-SC सिग्नल you have to add carrier signal. लक्षात घ्या, इथं AM मधून कॅरियर मायनस केला आणि DSB-SC मिळाला. रिसिव्हर मध्ये काय करावं लागतं? DSB-SC मध्ये कॅरियर सिग्नल ऍड करून फर्स्ट यू हॅव टू कन्वर्ट इट इन द फॉर्म ऑफ काय मिळालं आपल्याला? DSB-SC मध्ये कॅरियर ऍड केला की
AM signal.
AM सिग्नल. आणि ह्या AM चा आपण ज्या दोन मेथड बघितल्या त्या मेथडने आपण याचं डिटेक्शन करू शकतो. लक्षात येतं का कन्सेप्ट? डायरेक्ट DSB-SCचं डिमॉड्युलेशन होत नाही. पहिल्यांदा DSB-SCला आपल्याला कशामध्ये कन्वर्ट करावं लागतं? AM मध्ये. आणि एकदा आपल्याला AM सिग्नल मिळाला की आपण जे वरती दोन टाईप बघितले डिटेक्टरचे, एनव्हलप डिटेक्टर आणि रेक्टिफायर डिटेक्टर, ह्यातला कुठलाही टाईप यूज करून आपण AMचं डिमॉड्युलेशन करू शकतो. ओके, दॅट इज द बेसिक कन्सेप्ट ऑफ द DSB-SC. आता सिमिलरली SSB-SCचं पण काय करावं लागेल आपल्याला? SSB-SC डायरेक्ट डिटेक्ट करू शकतो का आपण किंवा डिमॉड्युलेट करू शकतो का? नाही. फर्स्ट यू हॅव टू ऍड
Convert SSB-SC into DSB-SC.
I will write here DSB-SC plus any sideband,
Then
whatever we have
AM.
decided. DSB-SC plus sideband ऍड केला की तो काय मिळेल आपल्याला, सॉरी
DSB-SC.
SSB-SC प्लस साइडबँड जर
signal.
म्हणलं तर आपल्याला इथं DSB-SC मिळेल.
DSB-SC.
आणि DSB-SC मध्ये जेव्हा आपण कॅरियर ऍड करतो ऍट दॅट टाइम वी आर गेटिंग द
AM.
AM
AM
signal.
signal.
Okay, so these are the things that you have to remember for detection of DSB-SC signal and SSB-SC signal. Okay, so based on that diagrams we have to see. But first you have to keep this concept in mind. Don't search for any circuit directly for DSB-SC demodulation. First you have to convert that DSB-SC in the form of AM signal, and then you can extract modulating signal from the AM signal. मग जो कॅरियर आपण मायनस केलेला आहे सेम कॅरियर आपल्याला ऍड करावं लागेल DSB-SC मध्ये. दॅट पॉइंट यू ऍग्री? जो काही आपला कॅरियर आपण मायनस केलाय ट्रान्समीटर मधून सेम कॅरियर आपल्याला रिसिव्हर मध्ये ऍड करावं लागेल. दॅट्स वाय whatever carrier we have subtracted, same carrier we are adding at the receiver. That's why this method it is called as the synchronization method, or this method it is called as the synchronous method. Synchronous म्हणजे काय, synchronization असतं. There is matching between the transmitter and receiver. इथं सुद्धा जो कॅरियर आपण ट्रान्समीटर मधून मायनस केलाय सेम कॅरियर आपण रिसिव्हर मध्ये ऍड करतोय, त्यामुळे त्याला काय म्हणतो आपण, synchronization method. Okay, are you getting the concept of synchronization?
Yes, ma'am.
Yes, ma'am.
Now we will see the block diagram.
Yes, ma'am.
Okay, बघा इथं ब्लॉक डायग्राम काय आहे. आता हा पहिला DSB-SC सिग्नल इथं दिसत नसेल नीट, लक्षात घ्या. हा कुठला आहे, DSB-SC सिग्नल. आपण DSB-SC डिटेक्टर बघतोय म्हणजे ऑब्विसली ह्याला पहिलं इनपुट काय असणार आहे, DSB-SC सिग्नल. Then that DSB-SC signal is given to the product modulator. DSB-SC signal is given to the product modulator, and another input for this product modulator. आता जरी आपण ऍड म्हणत असलो तरी इथे ऍक्च्युअली कुठली प्रोसेस होते, मल्टिप्लिकेशन होते. सो DSB-SC सिग्नल ह्याच्यामध्ये ह्या लोकल ऑसिलेटर थ्रू आपण कॅरियर जनरेट करायचा. Through this local oscillator we have to generate the carrier, and that is given as input to this product modulator. This is DSB-SC signal, one input to the product modulator. The another input for product modulator is carrier signal. And how we are generating the carrier signal? कुठून जनरेट करतो आपण carrier signal? From where we are generating the carrier signal? Where the carrier signal is generated? Through this local oscillator. लक्षात घ्या, हा प्रोडक्ट मॉड्युलेटर आहे. प्रोडक्ट मॉड्युलेटरला एक इनपुट काय दिला आपण, DSB-SC सिग्नल. वन इनपुट टू दिस प्रोडक्ट मॉड्युलेटर इज DSB-SC signal, and another input to the product modulator is carrier signal. And where the carrier signal is generated, the carrier signal is generated in the local oscillator. हा local oscillator मध्ये carrier signal generate होतो, and that two inputs we are giving to the product modulator. So same it is written here. Output of product modulator is V of T. V of T will be given as S of T multiplied by C of T. V of T is equal to S of T multiplied by C of T, and then that is passed through the low pass filter. या low pass filter ची frequency आपण adjust करतो as per our modulating signals frequency, and then we are able to get the demodulated signal at the output. आता याच्यामध्ये सुद्धा दोन पद्धतीने आपण डिमॉड्युलेशन करू शकतो. ब्लॉक डायग्राम कशी आहे, पहिलं इनपुट काय ब्लॉक डायग्राम मध्ये, what is the first input in the block diagram to the product
DSB-SC
modulator?
signal.
DSB-SC सिग्नल आपण कुठं दिला इथं, ब्लॉक नाही काढत मी इथं, फक्त लिहिते. DSB-SC signal कुठे दिला आपण product modulator ला. And what is the another input for this product modulator from this bottom side? Carrier
signal.
ह्या दोन्हीचं काय होतं इथं मल्टिप्लिकेशन होतं. म्हणजे प्रोडक्ट मॉड्युलेटरला काय म्हणतात आपल्याला आउटपुटला DSB-SC ला नोटेशन वापरलेलं आहे S of T into carrier it will be noted as C of T. म्हणजे इथं आपल्याला मिळतो आपला ओरिजिनल AM सिग्नल. मग इथं जी डायग्राम आपल्या सिलेबस मध्ये आहे त्यामध्ये काय वापरलंय ह्याच्या आउटपुटच्या पुढचा ब्लॉक कुठला आहे लो पास फिल्टर. द आउटपुट ब्लॉक इट इज लो पास filter. So this low pass filter will demodulate this AM signal and we are able to get what is the output of low pass filter. काय मिळणार आहे लो पास फिल्टरचा आउटपुट आपल्याला इथं मॉड्युलेटिंग सिग्नल म्हणजे जो आपला ओरिजिनल सिग्नल आहे तो आपल्याला मिळतोय. ही ह्या डायग्रामचं कन्सेप्च्युअल डिस्क्रिप्शन आहे. DSB-SC another input for this product modulator. इथे असं लिहिता येणार नाही पण स्टील I will write here. The another input for product modulator it is carrier signal. इकडून दिला आपण इथून इथं दिला carrier signal. ह्या दोन्हीचं मल्टिप्लिकेशन होऊन आपल्याला आउटपुटला मिळाला S of T into C of T. Then it is given to the low pass filter. आणि ह्या लो पास फिल्टरची फ्रिक्वेन्सी अशी ऍडजस्ट केलेली असते की वी आर गेटिंग द मॉड्युलेटिंग सिग्नल ॲट द आउटपुट. ओके सो जस्ट गिव्ह मी 1 minute. Okay, so this is the description whatever is given in the diagram. एक इनपुट असणार आहे DSB-SC सिग्नल, दुसरं इनपुट असणार आहे कॅरियर. आउटपुट will be S of T multiplied by C of T. Then it is passed through the low pass filter and output we are getting as a modulating signal. हा झाला बेसिक कन्सेप्ट जो आपल्या डायग्राम मध्ये एक्सप्लेन केलेला आहे. Another concept is that instead of this low pass filter, what another circuit you can use to demodulate the AM signal and get modulating signal at the output? लो पास फिल्टरच्या ऐवजी कुठलं सर्किट यूज करू शकतो आपण तिथं दुसरं? Which another circuit we can use instead of low pass filter? AM detector यूज करू शकतो ना आपण? We can use here the AM detector. Either we can use here envelope detector or we can use the rectifier detector. So that is also another option which you can select. But usually here in this diagram the low pass filter it is used and modulating signal it is recovered at the output. Okay, is it clear? हे इक्वेशन फक्त लिहायचं याच्यामध्ये. हे नोटेशन लक्षात ठेवा. DSB-SC signal is noted by the symbol as S of T and local oscillator is giving the carrier signal. So its frequency it is or symbol it is noted by C of T and output of product modulator it is V of T. So S of T DSB-SC signal local oscillator C of T याचं मल्टिप्लिकेशन होऊन येत आपल्याला V of T मिळतो and V of T given as input to the low pass filter and output we are getting as VO of T, that is the demodulated output. Okay, so this is the block diagram for synchronization method for DSB-SC signal detection. Is it clear?
Yes, ma'am.
Synchronization method. Okay, so same description it is given here. I will just read it once again. For this, we have to add carrier in the DSB-SC signal. Directly आपण DSB-SC signal demodulate करू शकत नाही. त्याच्यामध्ये आपल्याला carrier add करावा लागतो. This carrier is same as the carrier which we have used in the AM generation method. So this method it is called as the synchronization method or synchronous detection method. Then product modulator is used as first block in the receiver. One input to the product modulator is DSB-SC signal and another input it is carrier signal. Same as used for AM generation. And where the carrier is generated, with the help of local oscillator, carrier signal is generated. At product modulator output, we get addition of DSB-SC signal and carrier signal, and then it is passed through the low pass filter to remove the high frequency components and recover the originally modulating or recover the original modulating signal at the output. Okay, so this is the diagram of the synchronous method at the receiver for DSB-SC demodulation. So this one method only you are supposed to write in the exam. Is it clear to all?
Yes, ma'am.
Now the next method we have to see, that is for DSB-SC detection. SSB-SC detection नंतर कुठला असणार आहे दुसरा detection method, that is SSB-SC detection. मग मी आता तुम्हाला सांगितलं पहिल्या डिस्क्रिप्शन मध्ये SSB-SC च्या डिटेक्शन मध्ये कुठल्या स्टेप्स असतील. What will be the steps in the SSB-SC detection? Which steps will be there in the SSB-SC detection? काय करावं लागेल आपल्याला सांगा मला पहिल्यांदा. What will be the first step? Don't tell that diagram wise. मी जे तुम्हाला आता एक्सप्लेन केलं ते सांगा मला. काय करावं लागेल आपल्याला SSB-SC डिटेक्शन साठी? डायरेक्टली SSB-SC डिटेक्ट करू शकतो का रिसिव्हरला? काय सांगितलं मी आता? डायरेक्टली करू शकतो का? गिव्ह आन्सर प्लीज. करू शकतो का डायरेक्ट आपण
नाही.
रिसिव्हरला? काय करावं लागेल पहिल्यांदा?
SSB-SC चं कन्वर्जन DSB-SC मध्ये करायचं, परत DSB-SC AM मध्ये.
पुढची स्टेप तर सेम आहे, फक्त एक इनिशियल स्टेप ह्याच्यामध्ये ऍड होईल. दॅट स्टेप इट इज कन्वर्जन ऑफ DSB-SC इंटू द कन्वर्जन ऑफ SSB-SC इंटू DSB-SC. जे तुम्हाला आता मी वर्ड फाईल मध्ये लिहून दाखवलं होतं. सेम स्टेप्स यू हॅव टू अंडरस्टँड. ओके, सो DSB-SC here. Okay, I think I have erased that. Just I will write here. पहिला असणार बेस SSB-SC. SSB-SC मध्ये आपण ऍड केलं साइड बँड. SSB-SC मध्ये साइड बँड ऍड केला की त्याचं कन्वर्जन कशामध्ये होईल? DSB-SC मध्ये. आणि DSB-SC मध्ये आपण परत कॅरियर ऍड केला, याचं कन्वर्जन होईल AM. And in this way we are able to get the AM signal. And after this ही पुढची स्टेप सेम आहे. पुढची म्हणजे हे जे आहे DSB-SC पासून हे सेमच राहणार, फक्त याच्या आधी एक स्टेप ऍड होईल इथं. First we have to convert the SSB-SC signal in the DSB-SC signal form. Okay, then that will be converted in the form of modulating signal. Okay, so this whatever is this DSB-SC detection method, that method it is also called as the synchronization method, or it is also called as the synchronous method, because here also जो sideband आपण suppress केलाय, same sideband we are going to add and same carrier we are going to add so that proper modulating signal is recovered at the output side. It is quite obvious. आपण जर upper sideband मायनस केला असेल तर आपल्याला इथं कुठला साईड बँड ऍड करावा लागेल, अप्पर साईड बँड. इफ वी हॅव सबट्रॅक्टेड द लोअर साईड बँड किंवा जर आपण लोअर साईड बँड सप्रेस केला असेल तर रिसिव्हरला आपल्याला लोअर साईड बँड ऍड करावा लागेल. जो आपण तिकडे सप्रेस केला आहे तो सेम साईड बँड इथं ऍड करायचा आणि त्याला DSB-SC मध्ये कन्वर्ट करायचा आणि DSB-SC मध्ये कॅरियर ऍड करून that we have to convert it into AM signal form, and then with the help of this low pass filter we can recover the modulating signal. Okay, so this is the DSB-SC detection block diagram बघू आपण. What is the first signal? Now you only explain this block diagram. Anybody please?
SSB-SC.
Okay, SSB-SC दिला पहिल्यांदा. SSB-SC, here SSB-SC is noted by S of T. तो दिला प्रोडक्ट मॉड्युलेटरला. व्हॉट इज अनदर इनपुट? दोन प्रोडक्ट मॉड्युलेटर वापरावे लागतात त्याच्यामध्ये, कारण आपल्याला दोन वेळा इथे ऍडिशन करायचे. हा प्रोडक्ट मॉड्युलेटर 1 म्हणून याला लेट अस कॉल दिस एज प्रोडक्ट मॉड्युलेटर 2. व्हॉट इज इनपुट फॉर प्रोडक्ट मॉड्युलेटर 1?
SSB-SC and one side band.
SSB-SC and one side band. आता जर आपण USB सप्रेस केला असेल तर इथं कुठली फ्रिक्वेन्सी जनरेट करावी लागेल? USB ची. त्यामुळे इथं काय दिलंय? फक्त फ्रिक्वेन्सी ऑफ साईड बँड. जर अप्पर साईड बँड सप्रेस केला असेल तर इथं लोकल ऑसिलेटरने अप्पर साईड बँडची फ्रिक्वेन्सी जनरेट करायला पाहिजे. जर लोअर साईड बँड सप्रेस केला असेल तर लोकल ऑसिलेटरने लोअर साईड बँडची फ्रिक्वेन्सी इथं जनरेट करायला पाहिजे. सो दिस इज प्रोडक्ट मॉड्युलेटर. One input is S of T, another it is frequency of side band. So, explain now. Next step. What is output of product modulator 1?
DSB-SC.
DSB-SC signal. Then, what is next step?
Add carrier signal.
So DSB-SC मिळालाय त्याच्यामध्ये कॅरियर ऍड करायचा.
AM signal भेटते.
तो कॅरियर कुठे जनरेट होतोय? सेकंड लोकल ऑसिलेटर मध्ये.
Second
लेट अस
local
से दिस इज लोकल ऑसिलेटर 1 and local oscillator 2. So this carrier it is generated by local oscillator 2. Then it is added to the product modulator. And then output we are getting in the form
AM
of AM. And in front of AM signal we are adding the low pass filter and we are getting the modulating signal. Okay, is it clear?
Yes.
Equations बघा कसे येतील इथं. हा झाला. Let us say this is S1 of T. So S2 of T म्हणजे काय आहे? प्रोडक्ट मॉड्युलेटर 1 चा आउटपुट. So you can use any symbols as per your convenience. इथं कुठले घेतलेले आहेत आपण? ह्याला S1 of T म्हणलेलं आहे. इथली जी फ्रिक्वेन्सी आहे त्याला X of T म्हणले आहे आणि ह्याचा आउटपुट जे आहे दॅट इज कॉल्ड एज S2 of T. So S2 of T is equal to S1 of T multiplied by X of T. And here this product modulator's output AM of T it is S2 of T multiplied by C of T. आणि हे परत देतो आपण लो पास फिल्टरला आणि आउटपुट वी आर गेटिंग एज अ मॉड्युलेटिंग signal. So this is the diagram for DSB-SC detection and this is also called as the synchronization method. Okay, is it understood? Is it clear?
Yes, ma'am.
Okay. So 3 detectors we have studied. 3 type of detectors. AM detector किंवा त्याला आपण म्हणतो AM demodulator. Then we have seen the DSB-SC demodulator and next it is SSB-SC demodulator. These demodulators are there in this chapter. So the question can be asked on AM demodulator किंवा AM detector म्हटला तर you have to write envelope detector or rectifier detector. The DSB-SC demodulator म्हटलं तर in that case you have to write this synchronous method. If SSB-SC it is asked, this particular diagram you have to write. दोन्हीही मेथडला DSB-SC detection आणि SSB-SC detection च्या दोन्हीही मेथडला आपण synchronous method म्हणतो because whatever carrier we have subtracted, same carrier is added at the receiver, and whatever sideband we have subtracted, same sideband is added in the receiver. Okay, that's why these methods are called as the synchronous methods or synchronization methods. Okay, is it clear? All the AM receiver types?
Yes, ma'am.
So next point we will start, that is concept of series and parallel resonant circuit for bandwidth and selectivity. See the point. Concept of series and parallel resonant circuit for bandwidth and selectivity. So yesterday I had explained you some basic things related to tuning. So what is the concept of tuning that I told in the receiver? Tuning means what? Tuning चा अर्थ काय होतो रिसीव्हर मधला? रिसीव्हर मध्ये आपण ट्युनिंग करतो म्हणजे काय करतो?
फ्रिक्वेन्सी मॅच करतो.
रिसीव्हरची फ्रिक्वेन्सी आपण ट्रान्समीटर सोबत सिंक्रोनाइज करतो किंवा मॅच करतो. दॅट इज कॉल्ड एज द ट्युनिंग. अँड फॉर ट्युनिंग मेनली देयर इज कॉम्बिनेशन यूज्ड ऑफ 3 कंपोनंट्स. ट्युनिंग साठी जे आपण सर्किट यूज करतो त्याला म्हणतो आपण रेझोनंट सर्किट, or it is called as resonance circuit, which is used for tuning. So in AM, to receive the expected bandwidth selectivity, receiver is using this synchronization process, or the circuit whatever is used for this synchronization process, that is called as the resonance circuit. Okay, so I will explain it point wise. आपण काय बघतोय आता, कुठला पॉइंट बघतोय? Series and parallel resonance circuit. Series and parallel resonance circuit. So resonance circuit मध्ये 2 टाइप येतात, series and parallel, based on their combination of the components. Structure of the components, there are 2 types, series and parallel resonance circuit. So first circuit, what is, or first point in this, what is the objective behind using this resonance circuit? For what purpose the resonance circuit is used? कशासाठी वापरतो आपण resonance circuit? For tuning purpose. So for proper tuning between the transmitter and the receiver, this resonance circuit is used. And resonance circuit is nothing but it is combination of resonance circuit is combination of resistor, inductor and capacitor. Resonance circuit is combination of resistor, inductor and capacitor. हे कंपोनेंट आपण सिरीज मध्ये यूज करतो का पॅरलल मध्ये यूज करतो? Based on that we are calling that particular circuit as series parallel circuit or series resonance circuit or parallel resonance circuit. That is the concept of this point. Basic concept समजून घ्या. What is that concept? Are you getting that?
Yes, ma'am.
What is the objective to use the resonance circuit first? You tell me.
RLC.
It consists of RLC, resistor, inductor and capacitor. And based on their combination, we are calling it as parallel resonance circuit or series resonance circuit. तुम्ही स्टडी केलं का इकडे resonance circuit किंवा दुसऱ्या कुठल्या सब्जेक्ट मध्ये झाले का तुम्हाला? Resonance frequency, resonance circuit. Have you studied that?
Yes, ma'am.
So what is the कुठले कंपोनेंट यूज केलेले आहेत त्याच्यामध्ये?
Inductor and capacitor.
Inductor and capacitor. Most of the time inductor and capacitors are commonly used. Resistor is also used, but the main performance deciding parameters, ज्या parameter वरून आपण resonance frequency final करतो, those are the inductor and capacitor. So that resonance circuits are used in the receiver. Okay, so I will just show you some diagrams for this resonance circuits. resonant circuits which are used for the tuning purpose at the receiver. Okay, so series resonant circuit बघूया आपण पहिल्यांदा. Okay, so if you want to see the images for series resonant circuit, here RLC, those are used in series combination. RLC are used in the series combination. Here is some voltage source and this RLC are used in the series combination. Okay, this is series resonant circuit, or it is also called as the serial resonant circuit. Then what is there in the parallel resonant circuit? See, these RLC, those are used in parallel combination with this voltage source, that is called as the parallel resonant circuit. This RLC are connected in the parallel connection. Okay, so basic concept all of you are knowing of the resonant circuit. याच्यामध्ये काय होतं? What is the concept of resonant frequency? What is the formula for resonant frequency? Can anybody tell? कुठल्या याच्यासाठी सांगा, सिरीज साठी सांगा किंवा पॅरलल साठी सांगा. Resonant frequency, what is the notation for resonant frequency? FR, let us say. What is the formula for resonant frequency?
1/2 pi under root LC.
1/2 pi under root LC. Okay, so same point we are going to consider here. आपल्याला ह्याच्यामध्ये resonant circuit कसं वर्क होतं, that we are not supposed to see here in analog communication or AM receiver, but here we have to understand what is the basic function or what is the basic objective behind using this resonant circuit in the receiver. Okay, so here in case of AM receiver, resonant circuit is used for tuning between the transmitter and receiver. So whatever is the frequency of transmitter and receiver, त्याच्यामध्ये ट्यूनिंग करण्यासाठी किंवा सिंक्रोनायझेशन करण्यासाठी आपण रेझोनंट सर्किट यूज करतो. So there are two types of resonant circuit, parallel and series resonant circuit. So in series resonant circuit, RLC components are used in the series connection, and in parallel resonant circuit, RLC components are used in the parallel connection. So in AM receiver, to achieve the expected bandwidth selectivity of receiver, this resonant circuit it is used, or it is also called as the tuning circuit. And here there is one more factor in the related to the selectivity in resonant circuit, that is called as Q factor. Q factor म्हणून एक पॅरामीटर असतो resonant circuit मध्ये. If Q factor is high, circuit is more selective. Resonant circuit मध्ये ते सर्किट जास्त सिलेक्टिव्ह कधी असतं, when the Q factor is high, and the formula for Q factor it is given by Q factor is equal to 1 by R square root of L by C. This R indicates resistance, L indicates inductance, and C indicates the capacitance. If Q factor is high, circuit is more selective. आणि हा फॉर्म्युलाज आहे XL, XC. XL means what? Inductive resistance. That is given by 2 pi into.
स्क्रीन दिसत नाही.
Screen is not visible. So there is some issue, I think. From which point you are not able to see the screen?
आताच
कुठल्या point
गेली.
पर्यंत दिसले होते? आताच ना? Okay, just I will try to reconnect. And there might be some net issue. If it is not reconnecting, we will see that point in the next lecture. Okay, are you clear with this point at least? Resonant circuit आपण काय यूज करतो रिसीव्हर मध्ये हे सगळ्यांना समजलंय?
Yes, ma'am.
In next lecture again I will show you the diagrams for series and resonance circuit. So same diagrams you have to draw whatever you have studied in your which subject you have studied it? ICAD or NTA? कुठल्या सब्जेक्ट मध्ये आहे तुम्हाला रेझोनंट सर्किट? हॅलो,
NTA मध्येच
English
आहे.
hmm?
NTA मध्येच आहे रेझोनन्स.
Okay.
NTA and
Oh,
ECAD मध्ये related
सेम
आहे.
कन्सेप्ट यू हॅव टू एक्सप्लेन हिअर ऑल्सो. फक्त ते रेझोनंट सर्किट आपण काय यूज करतो हे बेसिकली लक्षात यायला पाहिजे तुमच्या. कशासाठी यूज करतो आपण रेझोनंट सर्किट याच्यामध्ये? फॉर व्हॉट वी आर युजिंग दिस रेझोनंट सर्किट?
ट्युनिंग साठी.
To tune the receiver with the transmitter. Okay, that is the basic concept. So we will see remaining point in this particular resonance in the next lecture. Okay, so almost that is the chapter number 4. Tomorrow I will just check if any point is remaining, that we will see. And whatever are the points remaining from the previous chapters. आपले 2-3 पॉइंट राहिलेले आहेत जे चौथा चॅप्टर कंप्लीट झाल्यावर आपल्याला घ्यायचे होते. That points also we will cover. Okay, so all of you just type your number and you can leave the meeting.